Section 36.5, Electric Currents and Magnetic Fields. So, a moving charge produces a magnetic field. An electric current passing through a conductor produces a magnetic field because it has many charges in motion. So we already established that a moving charge produces a magnetic field. And now we're going to talk about the electric current, which is just a whole bunch of moving charges, right? The magnetic field surrounding a current-carrying wire, a current-carrying conductor, can be shown by arranging magnetic compasses around the wire. The compasses, so let's just look at the picture. So when there's no current in the wire, the compasses align with Earth's magnetic field. So we have a bunch of compasses sitting on a piece of cardboard, and they're all pointing north, down towards the A. Then when you run current through the wire, the current makes a magnetic field. And how does it point? Well, the compasses show you that the magnetic field is now a circle around the wire. So it's pointing north is clockwise here. Let's go ahead and take a look at that video, which I've got right here. All right. So the current is going, oh, there is no current. You can see all the arrows are pointing roughly down this way towards the bottom of the screen.
Click this on.
And there the current comes on. And now it's going counterclockwise. The magnetic field is counterclockwise around. And then he turns the current off, and they all go back to pointing north. Then he's going to send the current going the other way. The current is now going down the wire, and the magnetic field switches direction. So now it's going clockwise. Now, if you spread, he turns it off, and now he's going to spread the field, the compasses out, so you can still see that the field is a circle even further out. It's going to be a weaker field, but it's still pointing in a circle around the wire. Okay. Turn it on again. And they're all still going in a circle around it. Okay, very nice. So that illustrates this picture. Now here's the trick. You've got this wire, and you can see the current is coming out of the bottom of the screen and then into the top. That's how it's going around it. It would be going counterclockwise if you look from this side. Now what happens if you take that Y and you turn it into a loop? Well, the magnetic fields loop around each other. And you can see because it's a loop, they're all going the same direction. The magnetic field is coming out of the middle and then going out over the loop and down the outside. So you just took this magnetic field right here and you've looped a bunch of wire around it. So now the magnetic field in the middle is getting stronger. If the wire is bent into a loop, the magnetic field lines become bunched up inside the loop. If the wire is bent into another loop, the concentration of magnetic field lines inside the double loop is twice that of the single loop. The magnetic field intensity increases as the number of loops is increased. So that's a neat trick. So the more loops, oh, and then a current carrying coil of wire is an electromagnet. It's electro because it's all from electric current. There's no iron or any material in the middle of this. It's just, there's nothing there. Air is not the magnet. The magnetism is coming from the fact that the current is looping around and the magnetic field is being made by the current carrying wire. So that is a current carrying coil of wire is an electromagnet. So here's the picture. You can see the iron filings line up in the magnetic field around it. And if you make the wire into a loop, well, now you've got the magnetic field looping through. So north is going up this way. It will loop around and come back in through the south. And now what happens if you take that loop and you make a few loops? Well, now you've got one long magnet. and it's also stronger. This is 6 times as strong as this one because there's 6 loops of wire here. So it goes along there and then out and around, and there's your magnetic field. I really like this picture. This does a good job of showing you just how it works. Now, you could put a piece of iron inside this loop, and the iron will be a magnet, and the electric coil makes a magnet, and that makes a stronger magnet. And that's what this says. Sometimes a piece of iron is placed inside the coil of an electromagnet. The magnetic domains in the iron are induced into alignment, increasing the magnetic field intensity. But beyond a certain limit, the magnetic field in iron saturates. So iron is not used in the cores of the strongest electromagnets. Where do you see the strongest electromagnets? In things like MRI machines and research labs. Oh, speaking of which, superconducting magnets can also be found in MRI, magnetic resonance imaging devices in hospitals. Have you ever had an MRI scan where they put you inside the loop? This lecture is long enough. I'm not going to start showing pictures of MRIs, but that's a great example of where you can see a really big electromagnet in everyday life. So, why does a current carrying wire deflect a magnetic compass? You need to be able to understand that, and if you're not sure, then go back to the beginning of the section and watch it again.